okay? My voice, my screen.
Yes, sir, you can continue.
Hello.
Yes, sir, yes, sir, you can
Am
continue, sir.
I am I clear?
Yes, sir, you're clear. You can continue. Yes, sir.
Okay. 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 Right, students. In the very last class, actually, in the due course of pedology, the last class we have discussed about the rocks and minerals, very fundamentals, and now today we will see the weathering of rocks. Weathering. What is the type of weathering? How many types are there? What is the impact of weathering? What is the impact of weathering on and weathering, and what is its role in soil formations, and what are the different factors are influenced on it. So in detail we will see in details. It's very simple. Today lecture is very simple and very short, but from this you can get some few questions. Okay, let's start. Right. Okay, students, for weathering, there is a definition in many literatures, or many authors have given different lecture definitions. But overall, I found that these three are quite reasonable and very easy to understand. Very first definition, I repeat, definition should be like a definition. Okay, very first definition is a process of disintegration and decomposition of rocks and minerals which are brought about by physical agents and chemical process. See, these two are very important. Weathering is a disintegration and decomposition. Disintegration and decomposition of rocks and minerals which are bought by the who bought this disintegration and decomposition by physical and chemical process leading to the formation of regolith. Regolith is nothing but an unconsolidated unconsolidated soil or mass. It is not like soil, it is very unconsolidated. Mostly when you dig a profile, very lower layer, very lower sea layer, or beneath the sea, you can see this regolith type of layer we can see. It is just very initial stage of weathering. Or if this definition is very lengthy, you can see another definition is broken down by the activities of atmosphere with the aid of hydrosphere and biosphere. Here also the same thing was. It's very simple, quite similar to that very first one. Explain the motto of the first is repeated in the second also. Whereas finally last one, very one line simple. The process of transformation of solid rock into parent material or regolith is called weathering. So these are the very simple definitions. Simply you can see very first definition is very scientific. You can see that it is a disintegration. Disintegration, it's completely disintegrating. The original form of rock will be completely disintegrated. After disintegrating, what will happen? The material will completely decompose by the chemical mean. Very first one is physical mean, and second one is chemical mean. So this is the fine definitions for the weathering. Where we can see next at what we are saying. Very first one, parent material. Naturally, weathering where should happen? If there is a presence of parent material only, the weathering will be started. It's the regolith or least upper portion. It's either it should be regolith. Regolith means actually regolith will be like this to some pebbles, small stones. It will be some. It will be similarly. It will be like this. Here you can see here, like this. So regolith or at least upper portion may be defined as unconsolidated and more or less chemically weathered mineral material from which soil are developed. Whether it should be very uppermost layer, either it should be regolith or uppermost layer, the parent material. It should be mostly unconsolidated and less chemically should be very less weatherable. In physical mean of weathering, you can see only breakdown. There will be no change any in its chemical combinations or its lattice structure. Whereas in chemical weathering, you can see the complete formation of new material, a new type of soils will form. Even the condition of the what kind of soils are completely, of course, what kind of soil is completely depend upon the parent material. But if the chemical conditions are completely favorable, you cannot see what kind of you can say complete diversion of formation of soils from parent material. Parent material will have some other characteristics, but the result of soil will be completely different because due to the chemical activity or due to the climatic conditions. Okay, now we will see what is the physical and chemical mean. Weathering. Now weathering is, how many types of weathering is there? Very first one, physical weathering, it's completely disintegration, completely breakdowning, disintegration. And second one, these two, and second one is chemical weathering. These two are very important in the process of soil formation, students. These two are very important in in soil formation, physical weathering and chemical weathering. And third one is there. This is also very important. That is called the biological weathering. Biological weathering. After when these two are completely completed, this one will be come into the show. So depending upon the agents taken part in the weathering process, classified into three types. Just I mentioned about it. Okay, next one. We will see. Now we will see about these three type of weathering in the coming headings. Right. So the different agents of weathering. What are the different types of agents of weathering? You will see in physical and weathering. What are the different reactions we can say, or different conditions? Physical condition of the rock. Completely physical weathering is complete physical conditions. Change in temperature, action of water. So these three will play major role in physical condition, in physical or mechanical disintegration. What are those? Physical condition of the rock, changes in temperature, action of water. In this action of water also there will be fragmentation and transportation, action of freezing and altering and wetting, drying, and action of glaciers. We will see all these things in a coming slide. And action of wind also. Wind will be play a very different role. Atmosphere, electrical phenomena. Mostly this is mostly we can, when there is a heavy rain and there is a big thunderstorms, you can see this type of conditions in physical weathering. Coming to the chemical weathering or decomposition, you can see this. You can see the decomposition comes under this type of reactions. One is hydration, it is nothing but addition of water. Hydrolysis, it is nothing but breakdown of hydrolysis of water. Okay. Okay. Hydration, hydrolysis, and third one is solution. Solution is nothing but what are the chemicals are present, the conditions, whether the solution is alkali condition or acidic condition. That condition will also that condition also will show the what is the condition of the rock. And carbonation is nothing but addition or combination of carbon dioxide. And the fifth one is oxidation, and sixth one is reduction. Under these six headings or these six reactions involved in the chemical decomposition. Whereas biological is a combination of these two, disintegration and decomposition. Mostly man means human beings and animals, and rest all our mammals will be take this, and higher plants and their roots. Mostly plants, especially this type of higher plants and their roots we can see in hill stations. We can see, or whenever you went to the some hill stations, or when you're traveling to the hill stations, even in Uti, Kodaikanal, you can see beside side, you can found visibly, you can see in side roads, you can see the roots will be penetrate into the rocks, and rocks will be broke down. So that breakdowning also will helpful for the weathering and formation of soil also. And third one is microorganisms. These are the final consumers. This is a microorganism also plays some important role in our soil development or in weathering. Okay, weathering is a disintegration process, students. Actually, it's a disintegration means some type of reaction. We will see what are those things. What is the next? Very first, we will see the physical weathering. Now we will see slow by slow. I mean, blow by blow. We will see the physical weathering. What physical weather is saying? Physical weathering is saying the rocks are disintegrated or broke down by the comparatively smaller pieces without producing any new substance. See, say for example, if you take any parent material, any rock, whether it's a granite or any parent material, it's only physically it was damaged. It will completely, the big rock will become into small rock by any other physical means, either by animals or something. Physically, the bigger rock or bigger substance will become smaller substance, but there is no change in its combination, in its composition, or in its any latter structure. Only the size was reduced. The size is very bigger, and later and the size will be reduced into small pieces. That is in a very first stage of weathering. What is the third one? The permeability of rock is most important single factor. Yes, the conditions of the rock. The rocks are very important. Say for example, students, your sandstone. A sandstone means if you have any, I think most of you have no experience, I think so, because you are BSc students. Where sandstone is, if you just take a sandstone and you rub in between your hand, you can see small particles will be comes out, because sandstone is very easy to weatherable. Whereas coming to the basalt is a, that is a igneous rock. That's an extrusive igneous rock. That this rock is formed under the upper layer of the earth layer. I mean, outer layer on the surface of the earth. You can see this formation of basalt. Basalt is a extrusive acid rock. Whereas it is the fine texture, so this is very difficult to physical. This basalt is very difficult to for physical weathering. Whereas sandstone is a coarse texture, so this is very porous. So that is very important. So the condition, the permeability rock also plays a major role in our physical weathering. And then one, unconsolidated volcanic ash weathers quickly. Yes, and even volcanic ashes or unconsolidated coarse deposits such as gravel also weathers very quickly. There is no problem in such conditions. And coming to the action of temperatures in physical weathering, like in physical weathering, this is another part, action of temperature. How the temperature will plays a role. The variations in temperature exert greater influence on disintegration. Yes, students, especially if you see that at daytime, the rocks are getting up, heated up due to the sun, and the night time the temperatures will fall, and naturally it will be contracted. You know all those things. When the temperature is when there is heavy temperature, there will be an expansion. There is the expansion. When the temperature falls during the night time, there will be a cool or contracted amount. This complete alternation of extraction and the contraction is the extraction and contraction. What will happen? The rock will be weakens and also crumbles. Rocks do not undergo any. When mostly you remember, students, the rocks heating up a rock is very. It's not such an easy task. It is very. It will take a very long time. What are the minerals within the rock also vary in the rate of expansion. Even different minerals have a different specific heat. Even I have given what is the conditions of specific heat. I have given in the previous lecture. Okay. So very first we will see what are the cubical expansion of quartz is twice as per feldspar. Yes, the cubical expansion is on quartz. The expansion is twice. Okay, and the common dark color rocks are subjected to fast change in temperature compared to the light color rocks. Naturally, dark colors. Naturally, we know, students, the dark color will observe the heat very well than compared to the light colors. So naturally, in rocks also, dark color rocks are observes temperature very high when compared to the light color rocks. So what are the conditions again in next what I saying continuation of previous temperature, the difference in expansion of minerals and rock fragment generated stress between the heat surface and cool surface. Naturally, students, if the what will happen, the in rock due to this alternating heating and cooling, what will happen, the heating the fragments, they what will happen, there will be created some stress due to the expansion contraction, expansion contraction. What will happen, due to this unexpanded parts, what will happen, automatically the rocks will be broken, it will be physically, it will be broke down naturally. So this process of what will happen, this breaking also will take place in a very different manner. Due to this expansion and contraction, what will happen, upper portion of the rock will be removed. This actually this removed or complete the bigger rock will be broke down. This type of removing of upper layers is called exfoliation. What is this exfoliation? We will see this is the exfoliation. Due to this, see students, due to this heavy due to the heavy alteration of temperatures, what will happen, the expansion and cooling, that is the main heating up, cooling up, expansion contraction, expansion contraction. Due to this alternating temperatures, what will happen, brittle and will be broke down. So this is called the exfoliation. Actually, there is an informal word in some literatures. There, the exfoliation we informally, this is not a formal word. Informally, it is called as a onion weathering. Just like, why? Because you can remove the onion peels very easily. It is just remove, just like this in rock also. It will move like a remove like a onion peeling. So that is naturally it is very informal, students. Don't use anywhere, because only in Chagall you can find this type of terminologies. But scientifically or formally, we should call it as a exfoliation. So due to this peeling of layers, peeling of upper layers is called the exfoliations. Remember, students, exfoliation terminology is very important. So example, this is the thing we can see. These are typical images for your exfoliation. We'll continue next. Action of water. Now, how water will act in a physical weathering. How water will act, we can see. Very first one, what are the agents of water will act as? Very first agent is disintegration. What water will do? Water will first, it will be break down. It will be disintegrate the rocks or parent material. And third one, that broken part will be transported. The broken part will be transported to somewhere. And third one, and the transported material will be deposited into the somewhere. Naturally, this will you can heard some terms called colluvium, alluvium. Actually, this type today we won't say all those colluvium, alluvium. We'll see next class, in the coming classes. These act as agents like disintegrating, transporting, and deposition. And finally, we will see what is the fragmentation and transportation. We will see the what will happen. Water beat over the surface. When the forceful of water are coming from a very high region to low region, what will happen? Rain occurs, started flowing from towards the ocean. Moving water have a great cutting and carrying forces. Naturally, when the water moves move some particular one area, what will happen? There will be greater cutting and carrying one. The rock will be cut and carried away to some other. What will happen naturally due to this heavy force of water flow? There is a formation of gullies, ravinaries. You have listened all these terminologies in your soil erosion classes, and carries with a suspension soil material of a various sizes. So definitely there will be different based upon the size, based upon different sizes. This water will be transported from different area and deposit in the another area. The transported power of water varies. Actually, it varies. Estimated that transporting power of streams varies sixth power of its velocity. That is greater the speed of water, more the transporting power of the carrying capacity. Naturally, when there is a great force of water movement, naturally the transportation or cutting and shearing effect of rocks will be more. What is based on the speed? What are the different carrying agents that take place? If the flow of water is around 15 centimeters per second, what will happen? The carrying it, that water can taken away your fine sand. If the 30 centimeters per second, even it took away gravel. If it is 1.2 meters per second, what will happen? The big stones, more than 1 kg capacity of stones can be removed away, can be carried by the water. Whereas if the water flow is 9.0 per meter, bulldozers with big tons of big rocks. Actually, it is practically even you can see these upper two conditions. Hardly you can see these upper two conditions, some questions, and these lower two conditions are somewhat difficult. Regularly we can't see. Only when there is a great disaster only we can see this type of conditions. Up to now, maybe most of we can see these two. So this is the condition of water in the transporting, and this is the water role of water in our weathering. What happened to the water? And water, another action of water is freezing and thawing. What will happen, students? Means, see here in this image you can see when the when water was filled in the crevices or in the gaps of this rock, what will happen? The water, when the temperatures was falls down, or when the atmosphere was completely cooled down, what will happen? Water was freezes and expanses cracks into the wedges. Naturally it won't go upper direction, students. It will go inner directions. Naturally what will happen, due to the ice becoming very frozen, it will go into deeper and deeper. What will happen? Naturally the single rock became into two, and again this process will be repeated. This is called the freezing and thawing. Actually this freezing and thawing effect is called as freezing and thawing effect. Due to the freezing, when the water comes into the crevices of the water, it will freezes and goes into deeper and deeper. What will happen? The rock will be splitted. This is another action. This is called action of freezing. This is one of the effect. Mostly you can see in very temperate regions, we can see this type of weathering. You can see these conditions are very favorable. Coming to the next, alternating wetting and drying. Naturally, students, actually these are actually this very easy. You see some natural substance increases considerably in volume on wetting and sinking. Example, smithsite and montmorillonite. Type of minerals, montmorillonite and all those things. That's why you can see that in summer you can see there will be shrinkage. You can see big crevices. Even some studies said that there is a 1 meter depth also. You can see that the cracks are in the deep of 1 meter. On a subsequent wetting, what will happen? It will be expanses. This altered shrinking and wetting clay enriches rock, make them loose and eventually break down. What will happen? Just like this. See here, actually the bedding means this a lowet. In summer, what will happen? The cracks will be very bigger. What will happen? In the same time, if there is a water, when there is a rainy season and the conditions are very good, means what will happen? The water will go inside. Naturally, there will be external lateral forces. Lateral force will be there, and water will be pushed lateral. Naturally what will happen? There will be breakdown of the minerals. There will be breakdown of minerals. Naturally there will be a release of nutrients also. You can see mostly you can see, students, in potassium you can see this type of situation. Potassium naturally it will fix in the interlayers of the clay lattice. That's why the potassium will fixes when the conditions were favorable, or when the water was came into favorable conditions. What will happen? There will be a release of the potassium. So this is the alternate drying. Next, action of glaciers. Student, this type of weathering you can see only in Himalayas and Russian conditions, or in any other glacial conditions. What will happen? This big glaciers move on changing of temperatures. Due to changing of, what will happen? It will move on the rocks. What will happen during this moving? What will happen? There will be some bombarding, hitting. What will happen? There will be some chance of weathering of rocks. Naturally, these conditions in cold regions, when the snowfall accumulated changes in the ice sheet, the big glacier starts moving on to changes in temperature. Due to the change in temperatures, what will happen? The big icebergs will be flow on moving the external tremendous pressure over the rocks and parts. Yes, I said just now. I said when these big rocks or big ice glaciers when flow upon the rocks, what will happen? They will put a lot of tremendous pressure on the rocks. And what will happen? Naturally, the rocks are loosened and they carry the rock material from one area to the another area. They deposit from the one area to another area of depositions will be taken place. Action of wind. Actually, this is the action of wind, students. Uh, Action of wind. What will happen? Wind has an erosion transport effect. Mostly this type of thing you can mostly find sand, silt, and clay particles. It has a serious abrasive effect, and sand lines will ultimately break down the rock. What will happen when these small sand particles are flown upon a rock? What will there will be severe abrasive effect. The dust storms of transport tons of material from one place to another, and shifted soil causes serious wind erosion. Even if these conditions was very heavy, what will happen? It will leads to a erosion problem. Mostly this type of action of wind problem we can see mostly we can see in Rajasthan, in Sahara, or even in our Thar desert also we can see this type of conditions of wind involvement in our physical weathering of our rocks. Next. This is the aerial deposition, students. We can see what is a weekend aerial deposition. Fine sand, literally fine sand or coarse sand depositions locally takes place. It is called aerial depositions. And desert sand dunes and dunes means this big. You can see in Rajasthan, you can see big sand dunes. Big accumulation of sand will be takes place in one area. It's called the sand dunes. You can see in next lecture we will see the ioline, alluvium, colluvium, and all terminology we will see next class. But today we will see only we are concentrating only on weathering conditions. And this one, atmospheric electrical phenomena. It is important, students, when there is a heavy rain and there is a big lightning and thunderstorms are there. This will be involved in our rock formation. Directly, sometimes the thunder will be carried into the will be felt on mountains or any rocks. What will happen? It will automatically it will be breaks down due to the electrical phenomena, atmospheric electrical phenomena. What will happen? The condition of the rock after that impact, it will be like this. The rocks will completely become a very small fragments and become very light. It will become small fragment or will be cracks due to this electrical phenomenon. It is important time during mostly in rainy seasons. Naturally, in rain there will be water, and if this water is compacted with about the physical weathering. Physical weathering is very simple. It is only disintegration. As we discussed in the previous slides, we have seen only physical disintegration, whether it's a big or small, all the rocks are just broke down, just physically it was broken down, but nothing was happened to its chemical combinations or its lattice structure or its previous characteristics. It's just become the physical mean completely. Bigger rocks become small rocks, and these small rocks, these small fragments has favored to the chemical weathering. Why? Because why, students, can anybody answer? The big rocks are become small pieces, and it was favorable to the chemical weathering. What is the reason? Very fundamental reason. Hello, hello, is I'm audible to everyone? Hello,
Sir?
yeah, I'm audible, right? Someone is chatting. Okay, fine. Why? Because please answer, students. It's not a one by so. The bigger rock. See, suppose there is a 1 kg of big rock is there. That rock was completely physically weathered and broken into small fragments. Now that rock is very favorable to the chemical weathering. What is the fundamental reason why the chemical weathering is favorable now than before? Than before the physical mean? What is the reason? Can anybody answer? What is the reason? Okay, I think no one interested. No, students, very simple, students. Just you take 1 gram of sand. Just you take 1 gram of sand in a small vial. Vial means small bottle. You just think how many sand particles are there. At the same time, you take 1 gram of clay particle in the same size of vial, or in a vial means small container. You see how many particles will be there. Whether in sand particles will we have more particles, or in clay will have more particles. Someone is answering. Yeah, Yeah, at least I got answer. Surface volume, yes, surface area will be increases. Due to the more surface area, more chemical reactions will takes place. So it's completely favorable for the chemical weathering. That is the main reason. Why? Because why? So anyway, I got my answer. We will continue the chemical weathering. So decomposition of rocks and minerals, whereas chemical process is called the chemical weathering. It is important soil forming factor, students. Yes, this is a very important forming. Even if you study the most of the pedological features, if you go to the pedology very deep, this chemical weathering plays a major role. Even if you want to characterize any area soils, only this chemical parameters will play a major role. Chemical weathering takes place mainly at the surface of the rocks and mineral disappearance of certain minerals naturally. And what will happen due to the heavy surface area? What will happen? There will be a disappearance of the major minerals, primary minerals, and leads to the formation of secondary products or secondary product, new minerals, new materials. Secondary minerals will be formed. This is called the chemical transformation. All your calcification, gypsification, laterization, everything is comes under your chemical transformation only. Now coming to third point, chemical weathering becoming more effective as the surface area of rock increases. Yes, when there is a 1 kg of big bulldozer rock is there, it is very difficult to break down. When it becomes small pieces, what will happen? The surface area will be increases. So naturally the area for the chemical reaction will be increased. That is why in most of our in agriculture point of view, our clay particle plays a major role in our soil texture or in a nutrient status also. Since the chemical reaction occurs largely on the surface of the rocks, they are therefore the smaller fragment, the greater the surface area per volume. This is a repetition of my explanation only. Greater the surface, greater the reaction. So naturally, the effectiveness of can be closely related to the mineral composition. Here also the mineral composition will completely decides the chemical weather. Example, quartz responses far slowly to the chemical attack than olivine or pyroxenes. Yes, quartz is very resistant to the weathering. In last class I have said quartz is very difficult to weather, even for the chemical attack also. But whereas coming to the olivine or pyroxenes, plays a major role in our chemical weathering. We will see next. We will see different headings. What are there? Very first, students, hydration. Yes, chemical hydration. Hydration means addition. It's nothing but addition of soil. So it's a combination, students. It's a combination. If any mineral is there, if we combine with water, there will be some chemical reactions will be there. Naturally, there will be exchange of water molecules or addition of water molecule. Or what will happen? There will be formation of new mineral or a new secondary mineral. What will happen here? In very first points I mentioned, chemical combination of water molecule with a particular substance or a mineral lead to the change in their structure. The structural component will be different. Soil forming minerals in the rock does not contain any water. Yes, students, rocks forming does not contain naturally in very coming very forth. Rocks may not completely, they won't contain any water. But under hydration, when exposed to the humid conditions, until when it was exposed to the humid conditions, or when there is heavy rain only, you can see this combination of water. Upon hydration, there will be a swell. Naturally, the minerals will be swell. They will expand. So the volume will be increases in the mineral. The mineral lost their luster. Naturally, if there is expansion, there is luster, and become luster means they're hardening and become very soft. It is one of the most common process in natural works are the secondary minerals, such as naturally leads to the formation of secondary minerals as aluminum oxides, iron oxide minerals, and gypsum. Here you can see, students, some chemical reactions. Olivine NGOs here you can see in olivine, if there is addition of water molecule, what will happen? It leads to the expansion and leads to the serpentine. The serpentine will be formed here. At the same time, hematite, what will happen? This hematite will completely actually it will be red in color before addition. When it's addition of what will happen? You can see yellow color. This type of actually, if you see this type of yellow coloring mottles on the profile, we will call it as mottles. That is different. We will read about those mottles in soil profile. And coming to the bauxite is very costly mineral. In bauxite, if is the addition of what will happen? Hydrated aluminum oxide. Due to the addition of water, what will happen? It leads to the formation of hydrated aluminum oxide. And generally, students, this calcium sulfate or anhydrated It will, if it's combined with water, what will happen? If there is addition of water molecule to this particular mineral, what will happen? It leads to the formation of water molecule. Simply, students, hydration means nothing but addition of water. Simply for your blind understanding, it's addition of water. Due to this addition of water, what will happen? The metal, the soil, not metal, the minerals will be, the rocks will be very soft and they lose their luster and completely leads to the formation of secondary minerals like aluminum oxides or iron oxides or minerals and gypsum. This leads to the, this is called the hydration. Okay, coming to the next. Hydrolysis. Lysis. In chemistry, you can see this lysis. Lysis means a breakdown. It's complete breakdown or dissociation. What will happen means, students, most important, this is very important process mostly involved in our chemical reactions, because here only there is a giving of H plus and OH minus ions. This imbalance in chemical reaction will plays a major role for leads to the formation of different compounds. Especially we can say it is due to the dissociation of water molecule into H plus and OH minus ions, which is chemically combined with the minerals and brings about the changes such as exchange. Naturally, exchange means if the our H plus ions will be exchanged with some other material, and in return they get some other material. You can in below you can see this type of reactions. In exchange, decomposition of crystal lattice structure. Naturally, there is a decomposition, means destroying of the crystal lattice structures and form and leave this completely. What will happen due to such type of reactions? The exchange and decomposition of crystal lattice leads to the formation of new compound. Naturally, water act as a weak acid on silicate minerals. Actually, water will act as a very weak acid, especially you can see in students in orthoclase. What will happen in orthoclase? We can see if it is combined with H plus ions, this water one one hydrogen atom or one hydrogen was attached to the orthoclase. What will happen? It's coming to acid silty clay. That's potassium hydroxide. Potassium was came out. Okay. One H plus ions was replaced with Al SiO3 and OH minus was combined with potassium. So that leads to the acid silicate clay. Coming to the recombination, this is the recombination means completely aluminum hydrated silica. This again, this repeat actually this should be here. Some problem is that. So what will happen again? It will again this H plus ions listed. What will happen? Aluminum hydroxide and silica acid was formed due to the H plus and OH minus ions. Okay. This is some sort of reactions in hydrolysis. Hydrolysis means it's a breakdown. This H plus and OH minus leads to the exchange and decomposition of the crystal lattice and leads to the formation of secondary minerals. And this reaction is very important. What is the reason, students? Why this hydrolysis is so important? Because of clay, bases, and silica acid, the substance formed these reactions are available to the plants. Actually, due to these reactions, what will happen? These reactions are available. What are the conditions are there? The released material, the released nutrients are very useful to the plants. Water often contain carbon dioxide. Naturally, due to the carbon dioxide, maybe sometimes or observed from the atmosphere or even from the respiration due to the result of respiration by the roots also, we can water will contain water and reacts with the mineral directly to produce insoluble clay minerals and positively charged materials. Naturally, it will react to the soil, react to the clay minerals, our secondary clay minerals, what we have discussed in the previous lecture, and this will leads to the formation of calcium, magnesium, sodium, and potassium. So these are the major important minerals which are needed for the plant growth. The natural negative charged ions, so hydroxides and SiO3 also will be formed, and some soluble silica. All these ions are made available to the growth. Naturally, due to this reaction, due to these exchange reactions, what will happen? Most of the plant nutrients are available to the plant. That is why this hydrolysis is very important. Coming to the solution naturally due to the mixing of different conditions. See, this is what I have said in the very first one. Some substance present in the rocks are directly soluble in water. If there's some combination, the soluble substance are removed by the continuous action of water and rocks, no longer remain solid and forms holes, rills. Yes, even you can see, students, in few areas we can see the upper surface of the rock will there will complete small holes will be there, tunnels will be there. Sometimes there will be complete removal of the upper surface of rock will completely removed. Why? Because of the some combinations of chemicals, some combinations of solutions. Example, the action is considered increasing water acidifying by dissociation of organic and inorganic acids. Actually, if the organic substances are completely, the example halides like sodium chloride, you can see if the sodium was a sodium chloride additionally added with H2, what will happen? Sodium chloride, H2, all this were dissolved in the water. So this dissolving, what will happen? There will be formation of some rills. Rills means some small gaps, some holes will be happen to the rock, everything. All this chemical disintegration due to the solution, due to this acid and alkaline in nature of the solution, what will happen? The rock automatically leads to the weathering conditions in the chemical mean. Coming to the carbonation, carbonation is nothing but it is the addition of carbon dioxide. H2 plus is carbon dioxide. What will happen? It leads to the carbonic acid H2O plus CO2 leads to carbonic acid. When this carbonic acid attacks the rocks and minerals, brings into the solution. So what will happen? This carbonated water has a itching effect. Itching effect means it's just like cooling the material. Some itching effect will be there on the rock, especially on lime, students. Especially on lime, what will happen? The removal of cement. Naturally, this itching effect leads to that holding particle. The cementing agents will be completely destroyed. What will happen due to the destruction? What will happen? The holding capacity of that rock, the cementing effect of the rock will be completely removed due to this acid, carbonic acid. Especially you can say calcite, it is very slightly soluble, or when it combined with this carbonic acid, what will happen? Lead to the calcium bicarbonate. So it is calcium bicarbonate is readily soluble in our water. So this is called the carbonation solution. So these are the important points to remember, students. Just in, I think mostly in AFO exams, they will ask very elementary questions from this fundamental weathering process. Very fundamental questions they will ask. Coming to the oxidation. Oxidation is nothing but addition of oxygen to the minerals. So oxidation is a more active presence in the moisture resulting in hydrated oxides. So naturally, if there is we added more oxygen, what will happen? It leads to the minerals will be completely hydrated, will become hydroxide. Especially if there is a ferrous oxide, FeO2 was added with oxygen, what will happen? The ferrous will become ferric, leads to the formation of FeO2. And magnetite, if you add the oxygen, it leads to the hematite. Same time, FeO2 is the hematite was completely added. Additionally, if you add it with H2O2, what will happen? It completely end up with limonite. So oxidation, even the addition of oxygen also will involve in the change in the mineral structure of our rock and leads to the formation of secondary minerals. So this is the importance of the oxidation in chemical reaction. And very final last one is the reduction. Reduction is nothing but it's the removal of oxygen or addition of OH minus and under the conditions excess waterlogged conditions, aerobic conditions. Well, what will happen? This type of reactions will be as there is no oxygen. What will happen? The hematite will completely reverse reaction than in the previous reaction. The hematite will completely reverse ferric will be compressed into ferrous. Complete conditions. What will happen? In conclusion, what will happen during chemical weathering? Igneous metamorphic rocks can be regarded as involving destruction of primary minerals and production of secondary minerals. These are the important lines, students. Please remember. What will happen? Finally, in conclusion, what should chemical weathering? In chemical weathering, igneous and metamorphic rock can be regarded as involving in destruction of primary minerals and production of secondary minerals. In sedimentary rocks, what will happen? Which is made up of primary and secondary minerals. Weathering act as initially to destroy the relative weakening bonds, the iron oxide bonds, and particularly freed the can be individually subjected to the weathering. Actually, in chemical weathering, there will be some bonding will be there in between iron oxides. What will happen? Bonding will be removed by this chemical reaction and leads to the formation of secondary minerals. And finally, these are up to now we have discussed about the chemical weathering. These are very important, students. Physical and chemical weathering are very primary source of weathering. Coming to the next one is biological weathering. And coming to the biological weathering, here it is actually this biological weathering is favored by due to the previous two reactions. Unlike what happened? Okay. And biological weathering is nothing but is involvement of the your biological organisms, like maybe it's human beings or animals. What will happen during the construction of our dam? Okay, I think the link was missed. Okay, students, now I'm clear. Students, now I'm clear. Is it audible to everyone?
So it is audible, sir.
Okay, now I will share it. I think in biological weathering we missed, right? We are in biological weathering, right? Okay. Up to chemical weathering we have completed. Finally, today the last one is biological weathering. After this biological weathering, we will end up the session. Okay. I'll start sharing. Right, students. Biological weathering. Biological. It's the involvement of the animals or biological sources. Naturally, this biological weathering, when it will happen, when the human beings, we human beings, what will happen? We may go to the construction site, we may dig the tunnels, we may construct the dams, we may destroy some rocks. In animals, what they will do, small birds. These birds will be, especially these worms, small worms. They will make tunnels inside the rocks. Some birds maybe scratch with their food with their brains, and what will happen, some ants, small termites, all those things, what will happen, they will soil dwellers, they will be inside the soil dwellers. And sometimes the earthworms also will be completely churning the soil. Actually, earthworms are called the friends for the farmers. So what will happen, this churning will be takes place. And rabbit, what will the rabbit will completely make tunnels inside the inside the soil and the subsoil layers. And all these activities were completely, everything is as naturally leads to the formation of weathering, or which leads to the formation of weathering, weathering in a biological mean. Okay, oh, this slide completely explains about what I have said. Higher plants, naturally students, higher plants, actually these higher plants, especially these higher plants of weathering, you can see in hill stations. When you travel by a road, if you see beside side by road, you can see big trees, papal trees, big trees will completely penetrate the rock, and that leads to the crevices and leads to the crack the entire part of the rock and leads to the formation of weathering. So these mostly higher plant roots also will play a major role. And also students, in addition, I'm adding, when these roots respire, they'll release the carbon dioxide. This carbon dioxide will completely join with the soil water. The soil water again will come into the carbonic acid. Carbonic acid will complete another, leads to the chemical weathering. So all these things, or even the dead plants of residues also, even the plants when they're dead, their bodies will release some acids. Even some microorganisms will act upon it, and that acting with that releasing of some organics will also leads to the withering of the rocks. So that rocks is completely finally end up with the weathering and formation of some soil. And microorganisms also, yes, microorganisms will play a role due to the, when we completely, as I said before, in the decomposition of plants and animals like moss, bacteria, and actinomycetes plays an important role in role. The extracted nutrients from the rock and N from air are alive with small quantity of water. In due course of time, the soil develop under the clusters of these microorganisms. Actually, when these microorganisms started decomposing any organic matter, or any dead plant or plant or animal body, what will happen, they will release some acids, or they consume some minerals in some minerals in the soil, and that leads to the excretion of some other acids. This again end up with the weathering. So another and also this, during this respiration, there will be release of some carbon dioxide from these microorganisms. This carbon dioxide will combine with some organic compounds and completely leads to the decomposition of minerals. So it is finally end up with the weathering. Okay, this is the completely lead of your weathering. I think this is the last for today. Thank you. This is a very simple, today is very simple lecture. This is very simple lecture, students. Okay, if you have any doubts, we can continue. Any questions, students? After getting any questions, we can later we go for a poll. Even last class also we didn't have any poll. Today we are I'm giving questions from last time class also. Okay, students, shall I go for polling? Students, shall I go for poll? Okay. All are asking for a poll. Okay, students, I'm asking question from last time, previous lecture also. Last time I didn't conduct any poll due to some very bad internet connection from my area. Okay, I'm launching the poll. Very first question, students, from the last lecture. Please answer. Please answer for this, students. You have 30 seconds.
Rocks are produced due to
Rocks are produced due to the solidification of magma below the surface of Earth. Very simple questions. In AFO, questions will be very basic, students. Very, very basic. Okay, I'm stopping the question. It's time up. Answer is mostly 71% intrusive rock. Yes, when the solidification is below the surface, it is called the intrusive rock. When it is combined above the surface, it's called the extrusive rock. Most of them are 71% is high. Okay. And next one. This one. Intrusive rocks solidified at a greater depth are called. What are those? Yes.
plutonic rocks.
Come on, don't say. Please answer. You're giving answer. Oh, internet connection is unstable. Okay, 40 seconds over. I think two students. I think only we. Anyway, it's a plutonic rock. Almost 86% were answered. Third one. Gis is a metamorphic rock formed from which rock? I mean, gis was derived from which rock? From which rock gis was formed? Gis is a metamorphic rock. From where gis was formed? Okay, 40 seconds over. It's a granite, students. I think one student answered marble. Marble itself is a metamorphic rock. Why are you giving an answer? Marble itself is a metamorphic rock. It's wrong. It's a granite. Granite just was formed. Okay, another simple question. Minerals that are original components of rocks are called. Okay. Only 5. What about rest? Rest all 9 people. Okay, it's time up. It's the primary rocks. Sorry, primary minerals. I'm sorry. Primary minerals. Actually, the original component of rock is completely primary rocks. From this primary, there will secondary will be there. And there will be accessory minerals which are not that much important. Some amount will be there. Those are called the accessory minerals. So one student attended the accessory mineral. It's the primary mineral. Answer is primary mineral. Okay, example of 1:1 clay mineral. Very simple question. 1:1 clay mineral. Very simple question. Oh, it's time up, time up. It's a chironate. Only 7 members have attended. It's a chironate. 100%, 7 members, 737. Okay, now say this. Hydrogen bonding result in the interlayer of, I mean, which interlayer? Lattice, we can say hydrogen bonding. Yeah. Okay, very less. What rest all are doing? Out of 9, only 5 members are answering. Okay, student, the answer is chiral. Due to this hydrogen bonding, there will be no expansion. Someone, two students were answered as Montemorillonite light. Montemorillonite is expanding type. How can you expect a hydrogen bonding in Montemorillonite light? It's a common sense. Don't do these mistakes. It's a chiral. Okay. Identify the volcanic rock among the following. Somewhat general type of question. Which is a volcanic type of rock? The general question, students. Please answer. Just give it a try. Please answer. Everyone should answer. Whether it's right or wrong, that's secondary. You should answer. Come on, students. Everyone should answer. You give an answer. Whether wrong or right, that's secondary. Okay, the time is almost coming 1 minute. Okay. Answer is Gabbro, students. Majority of answer is Gabbro. So Gabbro is the right answer. Okay, now answer this. Which one of the following is a non-expanding 2:1 mineral? Non-expanding. Read the question properly. Non-expanding 2:1 mineral. The Montemorillonite, bedlite, non-tornite, illite. Which one is? Only 6. Okay. It's time up. It's illite, students. Illite is a non-expanding illite. It's a partially expanded naturally. Also, it is a non-expanding also. Illite is our answer in given one. Okay, answer for this. Among which of the given rock is a volcanic extrusive in origin? Let me upper surface of area. Which one? Okay, it's only 6. What about rest of 2? 2 people or 2 students were not answering. Please give your answer. And 2 more. 8 and only 7 out of 7. Okay, it's time up. Your answer is basalt. How many times I have to say? Basalt is an extrusive origin. 10th one. Which one? This one. Which one is a metamorphic rock? Please answer. Which one is a metamorphic? Given the following, which one is a metamorphic rock? Your granite, marble, sandstone, or basalt? Which one? Very simple question. A very simple question. Please answer. Everyone should answer. Okay, it's a marble. It's a marble, students. In the given 4 options, marble is our metamorphic rock. Your basalt is extrusive, granite is intrusive, sandstone is sedimentary. So marble is your metamorphic rock. Okay. Answer for this. Exfoliation is due to. Just now we have completed. Exfoliation is due to. What is the factor? That upper layer will be removed. Why? How? Please, students. 5 members, only 5 students or 6 students are constantly answering. What about the rest? I don't know. Okay, it's, yeah, everyone answered correctly. Heating and cooling. It's alternate heating and cooling of rocks. Due to that, that upper layers will be removed. It's called the exfoliation. Okay, answer for this. The breakdown of large mineral particles into smaller particles by physical forces. What is it is called? It is called decomposition, disintegration, deflocculation, or weathering. Very simple questions. In AFO especially, the questions will be, I mean your bank exams, the questions will be very basic. They will test your basic knowledge, students. Remember that. Fundamentals are very important in any subject. Okay, 7 members. Please answer. 8 members. 1 person has answered weathering. Actually, students, everyone answered disintegration. There will be no disintegration in physical means. Only 1 student have answered correct. It's a weathering. Disintegration means your lattice structure will completely be disturbed. That happens only in chemical situation, not in physical force. In physical force, only weathering will happen. In physical force, you can't say decomposition, you can't say disintegration, you can't say deflocculation. Only in given options, only weathering will happen. Only one person have answered the right answer. In physical forces, it's weathering will happen. The given, read the question very properly, students. In physical mean there is no any disturbance in combination of your particular rock. So naturally, in the given options, the D is your right answer. Weathering is your right answer. Okay, don't see the below question, see your upper question. Hydration is a process. Please answer. Don't answer the second one question, answer only first one. Hydration is a process. This is also simple one. Only focus on pedogenic, non-pedogenic, morphology and weathering. These are only 4 options. Hydration is pedogenic process or non-pedogenic process, morphological or weathering. No one is answering why. Come on. Finally, hey students, don't answer this below one. This is not your answer. It's some technical mistake. Answer for hydration is a process. Only one student have answered. Come on, rest. My God, it's almost 1.5. What happened? Is it visible to everyone? Students, is it visible? The poll is visible to everyone? Oh, sorry. Only one student have answered for this. It's a weathering process only, students. Hydration is a weathering process. Then please answer. Okay, I'm going to next question. Okay, answer for this one. Weathering is whether it's a geological process or destructive process or combination of both or none of the above. Which one? Students, read the question properly. Weathering is which type of process? It's a geological process or destructive process or combination of both. Come on. I think no one is. Students, no one have answered correct answer. Very first, what is geology? It's a geological process. It's a formation of something. Geology, it's a study about mountains, terrains, volcanoes, etc., etc. It's a different process. In weathering, what happening in weathering in given options? Some big rocks are completely divided or disintegrated into different. Sorry, I should not use this in physical mean. If I want to say in physical mean, completely different to small. What will happen? The bigger one completely destructive. Everything is completely destructive. No one have answered correct answer. It's a destructive process. Geological process completely different. Geology is different. Geology is something which is development, leads to the development. But weathering is not like that. After geology only we can see weathering. So what is that? It's a destructive process. Remember students, this is a, no one have answered the correct answer. Okay, answer for this. Which of these processes change both particle size and composition? In the given options, read the question properly and see the options and answer. Read carefully, take your time and answer properly. Okay, good. What about rest all? Come on, answer. Good. Timing going up. Come on, rest all. Oh, it's almost 1 minute, students. Please answer it, okay? The answer is hydrolysis. Only in hydrolysis we can see the particle size will be reduced and composition is completely changed due to that chemical reactions. Due to that reactions, what will have just now I said in solution form, what will happen? Due to that solution, the itching will be happen. Due to that lysis, due to the presence of H plus and OH minus ions, there will be formation of another different components, secondary components. Only this type of things will happen only in hydrolysis. Listen the lecture properly and see the questions. Okay. Okay. For today, this is the question, students. If you have any doubts, you can please answer now. Any questions are welcomed. Any doubts or any questions or need any clarification in the lecture, you can ask. Please respond. If there is no question, you said okay sir, no problem. Either you should have a good knowledge on pedology. Okay. Any questions? So all are very good in withering. Okay. I think I'm not expecting any questions. I think you have another class. Who is the host today, madam? Shall we?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
I'm not okay, getting any questions here. Shall we wind up the
Okay.
session?
Yes, sir. Yes, sir. We can wind up the session.
Okay, students. Thanks for your cooperation. And in a coming class, we will see about the pedogenic process and all those things. Thank you very much.
Thank you. Thank you so much, sir. So the next class will be at 8 o'clock. So now you can leave the meeting. Thank you.